Okay?
So that you will.
So we're going to have about 5 minutes to read the section, understand it a little bit, and then you're going to teach your partner, our partners, okay, what the experiment was. So I need two things. I need what the experiment was, and then what does it mean. Okay, why do we care? Questions about the procedure? Alright, so at 13:39, you're going to start sharing. Okay? Ready? Go.
First one.
In 1928, the Danish that guy was investigating into a conflict called
So just kind of explain what the experiment was. And then
Therefore, only was bacteria colonized to diagnose bacteriogenetic mice with combination of as bacteria which are bacteria to spread the mycelium, which has been found live as bacteria and parasites from the mice some bacteria must have been transplanted from the as bacteria to the live R material. Whatever material was contained information that changed harmless R material and disease causing as bacteria. Page called this mystery material the transformed principle.
You don't have to read this. This type of virus called bacteria for short takes over bacteria genetics more viruses. Like one person to study a relatively
Use of the chemical elements are that's offered.
question once for all. First she thought that she was talking about very little while DNA became
Next,
Next. Hershey and Chase
Okay, both you and your partner are done reading. Go ahead and start sharing. If you still need to read a little bit more,
that had DNA type, radioactive phosphorus, radioactivity was present inside the bacteria. So what we're you guys explain was that so he was investigating T-horns of bacteria that cause pneumonia. And those two forms. One form was made of carbon hydrate, and it was called the S form because it was active. And then the other form of bacteria was called the R form. Yeah, this is the smooth form. Yeah. Smooth form. So the next he goes and he tested on the yeah.
you guys ready to share? Are you guys partners? Do you end up switching partners back here? Who's going first? What? what happened in the experiment.
And then he injected even more space. Anyway, which
Okay, so you said that we could kill one of them, right? So basically, they So they infected the bacteria.
and then they
Look at this picture.
either way. Anyway.
If they gave them S bacteria and killed it,
Says when they send them
if they gave it to R, so the R will still alive. If they just give it the C kills S, then but if they give it the E kills S and the live, why don't So the S bacteria, no, sorry, R bacteria that was dead was able to absorb the DNA from the S bacteria and create more cells. That makes sense. Alright, let's see about the second one.
Or you
Moral
can
is
just that.
scientists kill
I was just like,
Alright, just another 30 seconds or so to finish explaining your experiment. And we're going to talk about it as a class.
why do people think I don't want to eat this? This just says, none of which are Netflix and chill.
Why did everybody get quiet? You're supposed to finish this. You're all finished? Alright, so let's talk about it. Alright, so who read about Avery and Company and would like to share what happened with them? Nobody read or nobody wants to share? Come on, brave souls. Who can tell us at least part of it? Not perfect, just part of it. Nobody? Okay, by show of hands, who read Avery? So I know that somebody read Avery. Okay, we have a volunteer back here. Okay, what happened?
So he tested different bacteria on mice, and there was one bacteria that killed mice, and another one that wouldn't kill them.
Okay, so what are those called?
The one that killed them was the S bacteria.
We have S,
And then the one that wouldn't kill them was R.
R. So harmless, lethal. Alright, go ahead.
And then if he killed the S bacteria, then the mouse would live.
Mhm.
And if he killed the S bacteria and put in the R bacteria with it, it'd kill the mouse.
So who can tell me what are we talking about when you said heat killed, right? What are they doing here? The bacteria. Okay, I know I'm not that scary, guys. Just make a guess. Okay, we're all learning something new. Let's make a guess. Yeah, basically killing the bacteria. They're making it so hot that the bacteria dies, right? Okay, and so you said when they killed the S and then injected it in the rats, or mice. The mice lived, right? When they injected, or when they killed it and injected both the dead S and the live R, the mice died. Okay, so why is that? Somebody knew that read Avery and Company. Okay,
Something was like transformed between them.
something was transformed. Okay, so even though,
Our bacteria was turned into S bacteria.
yeah, exactly. That even though this was dead, the DNA still existed. And the R bacteria absorbed that DNA, and then when it reproduced, it produced more S cells. Okay? So scientists started thinking, okay, maybe it's the DNA then, because the DNA got absorbed. Okay, so this brings us to, I like Hershey, right? Who doesn't like the name Hershey? Hershey and chocolate. Hershey and Chase. Okay, who had that one? Okay, what happened?
They were trying to prove that in DNA it was genetic material, not proteins. And so they found that protein contains sulfur, not phosphorus, and that the DNA contains phosphorus, but not sulfur. And they grew the, whatever it's called, phage.
Mm-hmm.
And then they tried to see if it was, they tested the protein to see if it was radioactive, because they were something would act with the sulfur. And then they tested genetic material, and then they saw which one was, tested the DNA, and which one was radioactive, right?
Mm-hmm. Yeah, exactly. So they got two radioactive isotopes, okay, which are easy to detect. One of them would attach to the protein shell. Okay, so it has a picture in the book, right, of a phage. It's like, I don't know, something like this. Like a little swirly thing, and then it attaches. Okay, and then the DNA is in here. Okay, so they had one radioactive isotope that would attach to this protein shell, and one radioactive isotope that would attach to the DNA. So they ran two different experiments, added their isotope, and then they saw which one stuck, basically, okay, with the next generation. So if it attached to the DNA, it would be passed on. If it attached to the protein, it would remain behind. Okay? So, I'm getting a lot of so what looks, right? So what? Why does this matter? They killed some mice. They messed around with some phage, which we don't know what it is. So what? Who can answer that?
It kind of told them where they should look when they're studying genetics, that they shouldn't just focus on the protein, they should focus on the DNA, because that was actual genetic material that would be passed on to the next generation.
Right. Without understanding where this genetic code was, they couldn't start deciphering it. Okay? If I would have done a better example of modeling it, maybe I would have hid the original code around the room somewhere, and then you find it before you could break it. Okay, that's kind of what it was. They had to find the code. They had to find where it was. Okay? And so, the rest of the lesson, we're going to talk mainly about what DNA is. Okay, the structure of DNA. Okay, another question. Because, again, I'm getting a lot of, okay, DNA, it's awesome. Why do we need to learn about DNA? Why is it important to know? Think about that for a second. Okay, now I want you to turn to your partner. Okay, same if you were in trios before, the same trios, and answer that question. Why do we need to know and understand DNA?
It doesn't look like an arrow.
But it's just a big those their babies go and they go out.
Oh, I know.
Anyway, so I need to write something.
Alright, let's come back together. Alright, who came up with some reasons? Why do we need to understand DNA? This corner of the room has been quiet. Let's hear from this corner of the room. I heard you talking.
Come on, Corinne.
I just said that it's important to have DNA because we wouldn't be here without it.
Okay, we wouldn't be here without DNA. Okay? Why else? Why is understanding DNA important?